Dear colleagues, ladies and gentlemen, we have just been presented a very impressive panorama of the changing concepts of time, well, in the mind of the people we are studying actually as historians, as archaeologists by Professor Klein. I will take a slightly different viewpoint because I will actually focus on the different concepts of not only concepts but also scales of time in the mind of archaeologists. So, but you will recognize maybe some points again. Well, the question of time in archaeology is of course a very crucial one, as has been pointed out already. So whoever works in archaeology uses time in some or the other way. But amazingly, it's quite amazing that at least in German-speaking archaeology, the theoretical reflection on our concepts of time as archaeologists are rather rare. When I really checked for the literature of the last decades, there were only very few articles that are explicitly connected with the function of time and not maybe the function but the concept of time on a theoretical basis. So despite our concern for chronology and dating, which is of course a basic methodology, there's comparatively little research on theoretical concepts behind our dating practice. There are now, in the last decades, I think we can observe a growing interest in time perception, at least within the Anglophone archaeology, and I would just mention the work by Gavin Lucas from 2005, The Archaeology of Time. Of course, there are some others as well. Well, I will deal with this concept of time and the question of time scales as seen from the statistical scale theory. And I will come from this point of view to our different ways of working with time. Scale theory distinguishes between different scale properties, and I will address the question whether these scale properties actually affect our archaeological reasoning. Some questions that I'm going to address are here. So one of the questions is, are chronological systems determined by the dating methods that we use? And to go further on, how does time scale influence our archaeological arguing? What is the role of probability in archaeological dating and reasoning? And maybe in the end, what might be the future of dating the past? So, to start with timescales, Stevens, a mathematician, American mathematician, defined different scale types in statistical theory in 1946. So he distinguished actually 4 types. I'm not going to talk about the nominal scale, which is, I think, not relevant to time, but the ordinal scale, the second level of analysis of scales, is defined by him that it gives only a sequence, but it does not specify the intervals between the units of a scale. As a contrast, metric scale that we all use when we measure anything means that there are equal intervals between the scale units, but still there are two different types of metric scales, the interval scale and the proportional scale. I will come to this point later. And another criteria would be, of course, whether we measure continuously or we measure in discrete units. So actually, when we are talking about relative chronologies, we are using the ordinal scale from this mathematical point of view. So most of the early thinking about time in archaeology is actually expressed on ordinal scales. And the principles of these ordinal scales are that time cannot be measured directly. So what we actually do is to determine time or express time by a sequence of events or processes, and this sequence of events is actually expressed by relations or a set of relations. These relations we observe between non-temporal entities or variables. So these non-temporal entities are used as a proxy of time. We are not talking about time directly. And the first and probably most important, at least from the point of view of history of research, the first time proxy is similarity. That's what we might call typological time. So at the very beginning of this concept of using similarity, as we have just heard also, is of course the typological method of Oscar Montelius. Another further development of this ordinal time scale is seriation. So if we start with Oscar Montelius' concept of typology, of course he, as we have just heard, he ordered types in series, and within these series he claimed that there is a continuous change. So we have actually change that can be expressed as decreasing similarity. So it's a gradient of similarity from very similar to very unsimilar. And what he actually writes in his famous book Die Methode in German, published in German in 1903, so that within a typological series we have very small, sometimes undistinguishable differences between neighboring types, but we have little, if any, similarity between the types at the beginning and the end of the series. So it's the basic concept is really a continuous modification of shapes over centuries, and this obviously presupposes that there is a continuous process. It cannot be interrupted somehow. In this case, a typology would not work. The Swedish archaeologist Mats Malmar pointed out already in 1962 that there is a structural relationship between Montelius' typological method and what we now call seriation, which was in the 1960s a rather new approach. I won't go into more details how he really argued, but one can really show that the seriation approach is actually the continuation of typology without the biologistic paradigm. So seriation does not need the concept of evolution transferred to archaeology, but it can be shown to be derived from the typological method. Now, I just showed two quite early examples of seriations. It has been common to distinguish between incidence seriation and abundance seriation. So just to take the occurrence of types or the quantity of types, and just two examples here. One of the analysis of southern German urnfields by Hermann Müller-Karpe, first published in 1959. And it was one of the first published seriations in the German literature, archaeological literature. And on the right hand, we have the famous abundance seriation of British beaker types published by David Clark in 1970. So just as an example, and of course every one of you knows the basic principles of this approach. Apart from similarity as time proxy, we use also spatial relations as time proxy. And spatial relations are the basis of both stratigraphy and what we call, in German at least, and I'm not very happy with this term, horizontal stratigraphy. So both are actually based on spatial relations as time proxy. In stratigraphy, this is quite obvious. It's a method that has been used as a in order to get ordinal time scales from the late 18th century in geology and from the early 19th century in archaeology, but only quite late there was really theoretical discussion about the principles of stratigraphy, and I think one of the, or maybe the most important person to name is Edward Harris, the English archaeologist who published Laws of Stratification in his book in 1989. And he also introduced the concept of interface being something that represents time in an archaeological stratigraphy but does not leave volume behind. So it might be this destruction, it might be the actual shape of a ditch or pit. Very important concept, I think, at that time. And of course he also introduced the graphic representation of stratigraphy as the so-called Harris matrix that is now very widespread in use. Mathematically speaking, we could express stratigraphy as a set of inequations of the shape that the time of the upper feature is younger than the time of the lower feature, but actually it's a set of inequations because we usually don't have the whole stratigraphical sequence at once, but we have different parts of it, and we could treat this as actually a set of inequations in a mathematical sense, and that is what is being done by algorithms that are used in programs for Harris matrix analysis. A similar concept, taking spatial relations as proxy of time, is in horizontal stratigraphy. Again, an early example of the Urnfield of Kelheim, published by Hermann Müller-Karpe in 1952, and he could show that actually the spatial use of this Urnfield develops with time. So it starts in the left part, in the western part of the Urnfield, and it develops slowly to the right part, to the eastern part. Actually, horizontal stratigraphy has never been, as I conceive it, never been really established as a full-scale chronological method. Many archaeologists have used it as a kind of additional evidence, which was meant to support their chronology based on seriation. But in some instances, when you date a grave that doesn't contain any grave good, this method can really be used, or has been used, to give an indication of the dating of the grave. Now, when we return to the statistical approach, to the statistical methodology of how we work with scales, mathematicians tell us that in ordinal scales we are allowed to do only special operations. So the only permissible operations that we are allowed are actually putting events or points in a sequence. So I don't know whether this is correctly translated as stringing entities, and counting frequencies, but not comparing frequencies. So inadmissible operations on an ordinal scale are measuring. We are not allowed to measure, and we are not allowed to build ratios between frequencies. That's very important, and the consequences for archaeological application are quite obvious. If we want to analyze the temporal dynamic, the growth, the drop, acceleration or retardation of cultural processes, we are obviously not able to do this on an ordinal timescale, just for methodological reasons. And the frequency counts of units, certain types, certain burial rites or whatever, on an ordinal scale cannot be compared quantitatively. This is quite obvious, but it's not always followed. And just to give you an example, I might quote an article of Christopher Pear about chariot graves in the Hallstatt period in southern Germany, and he published this table, and he distinguished between proper chariot burials which contained also the horse gear, and more symbolic chariot graves where no chariot is given but the horse gear. And he summed it up, and his conclusion was that the frequency of chariot burials in southern Germany decreases in the course of the Hallstatt period. So if you see the sum in the right column, while at the same time the burials become richer. And his consequence was that this might be a process of the concentration of power, so fewer burials which are richer equipped. But if you actually break down this table into not ordinal but a metric scale that is on absolute chronology, things look quite different. Because if we look at the frequency of chariot burials per year and we use the chronology that Per has used, we see that from Hallstatt C to Hallstatt D1 it's the same frequency of chariot burial, and only in the last stage of the Hallstatt period, Hallstatt D2, D3, there's actually a decrease. And if we change there's still some discussion about the absolute chronology of Hallstatt age. If we adopt a slightly different absolute chronology, things are even reversed. So at first the frequency of chariot burials increases, and only then it decreases. So this is just meant to show that we should really be aware of these scale properties of our chronology as we use it in archaeology. Now I come to chronological systems. Lucas, in his book 2005, distinguished between primary and secondary relative chronological systems. And by primary, he meant just the relative sequence of finds and or contexts that has been empirically assessed by one of the methods I've just been talking about. Secondary or derived chronological systems, according to Lucas, are generated by the combination or correlation of primary systems. So, to give you an example, I took a publication of Ursulescu on the chronological systems of Cucutanean Tripoli culture, and even if it's maybe hardly readable, I'm sorry about that. The idea is that chronological systems of Cucutanean culture are compared, which are published by different authors. So this is one type of such relative secondary relative chronological systems. Another one would be to take relative chronologies of different neighboring cultures. But the idea is the same. We compare, we correlate, and we derive such a system from primary chronological systems. Another example would be the so-called horizon approach introduced by Hermann Parzinger in two of his works. So he was faced with the problem of comparing chronologies in different regions with different chronological terminology, and therefore he introduced a kind of neutral horizon that should connect just different steps, different stages in different chronologies, and he explained this with this drawing that this does of course not mean perfect contemporaneity of all these stages, but the stages are just hit at a certain point in their life, and this is used for correlating different chronological systems, what he did in his work in his habilitation published in 1993, when he actually treated the chronology from the eastern Taurus mountains in southeastern Turkey up to Hungary and eastern Central Europe. This brings us to the question of terminology of prehistoric chronology. Everybody uses chronological terms, but I see that there's still little discussion about the standardization of this terminology. So just to give a proposal here, what I'm following Manfred Eggert in this point. So the uppermost stage in this hierarchical terminological system would be the epoch. For instance, Bronze Age. Then we would have the period, for instance, Older Iron Age or Montelius period 5. Then we would have the stage, for instance, Latin B. We would have the phase, and we would have subphases. Some chronological systems even are finer resolved than that. But in general, we use such hierarchical terminologies, but there's not always broad correspondence between different archaeologists, whether stage and phase are really in this way ordered or in the other way. So the hierarchy is not commonly agreed upon by everyone. There's obviously a tendency of refining, a continuous refinement of chronological systems. The question is, will we always be able to continue this refinement, or are there any intrinsic limits of such refinements? And I'm quite sure that there are, because we have actually to think about the limits of time, of temporal resolution. There are limits by methodological grounds and also by other reasons, which I will come back briefly. Geology and archaeology, and to a certain extent also history, are some of the disciplines that use ordinal scales for expressing time. The natural sciences use metric scales for expressing time, at least mainly. We have seen just how these concepts developed over the centuries. So here we have such ordinal time scales, one from geology and one from archaeology of southern Central Europe. I won't go into any details, but what you see is that they are hierarchically ordered. So we have always on the left side the bigger units, and on the right side the smaller time units. There are special cases of such hierarchical time systems, chronological systems, and one of the most fascinating examples, for me at least, is the Bronze Age of the Aegean. It was, of course, according to, or as a consequence of Thomson's three-period system, of course, we have the Bronze Age as the major period. And for the Aegean, it was called Helladic. And then it was subdivided into early, middle, and late Helladic. These were also subdivided in 1, 2, 3, 1, 2, 3, and 1, 2, 3. But this was not enough, so at least for the late Helladic, there were further tripartitions, 1A, B, C, 2A, B, C, and so on. So what we actually have is something like a fractal pattern here. So time is reproduced in a similar way on different levels of time scales. And of course this would be interesting to ask, why is tripartition so very popular in temporal analysis? Gavin Lucas gave some indications in his book, and he wrote about this tripartition. Maybe it's also one point is that it's a continuous development, continuous refinement, and the other one is that tripartition is not only something that is very rhythmically pleasant for our mind, but it's also the way how we actually argue with temporal development, because once we have found out there's a phase, the next generation will find out that this vase has an early expression and a late expression, and we have another tripartition. So this repetition of tripartitions is something that might be very specific for our way to argue in chronological systems. Now I come to metric timescales, and I've already pointed out this distinction of Stevens between proportional and interval scale and ratio scales. So proportional scales have an absolute zero. And there are few examples in archaeology or in history, but in a certain way I would say that the Roman historical calendar system is such a proportional scale. It has an absolute 0 point, at least in the view of the Roman historians. But otherwise, proportional timescales are rare. They would be expressed mathematically as a ray with a 0 point and an infinite positive upper, not limit, but it goes to positive infinity. Actually, what physicians and other natural scientists use is an interval time scale with an arbitrary 0 point, and that's actually the basis of all modern time scales as far as I see, at least. So the time axis is actually not a ray but a straight line. It reaches from minus infinity to plus infinity. Of course, this is not accurate concerning Einstein's concept of time that we have just been heard from Professor Klein. The other question is continuous or discrete. So are time scales continuous or discrete? As far as I see, our archaeological time scales are always discrete. It might be that we use millennia, like in the Paleolithic centuries, or generations, like in early historical archaeology, or even years, as with dendrochronology, but we won't actually get beyond years. As a contrary, in physics, there's usually a continuous time scale, so the accuracy is only determined by the precision of our time measurement, but not by the time scale itself. Time resolution. It depends, of course, on the method. So, for example, with dendrochronology, we might be able to date up to 1 year in very good situations. In radiocarbon analysis, we might be able to date plus minus 30 or 35 years, not regarding calibration, which I'm coming to in a minute. But time resolution also depends on the context. So, for example, the burial of a 60-year-old man, if we don't know whether the grave goods have been recently produced just before his death, or whether it was something that he was given as a boy, we are not able to distinguish between that. We have an intrinsic uncertainty, and this intrinsic uncertainty was obviously already aware in the analysis of Oscar Mantelos, because he already explained about this fact. So we won't be able to push time resolution to the very limits on that ground. So, in metric timescales, we have, of course, the calendaric scale, which can be either directly expressed if we use historical dates, or if we use dendrochronological dates. In case the sapwood, the last tree ring, is preserved, we get it to 1 year. But we also, if we are cooperating with geologists, geographers, we are also confronted with indirect, with proxy scales that are also measured on a metric scale: varves, laminated sediments, ice cores. So just to remind you of the dendrochronological differences, if only the core is preserved, we have only estimates. If the sapwood is preserved, we have a kind of terminus post quem. If the last tree ring is preserved, we can really put the date to 1 year. What is most important in the last, or has become most important in the last years, is actually probabilistic time measurement, expressing time on a metric scale, but expressing this in a probabilistic way. Actually, all our radiometric dating methods, but also thermoluminescence and optical stimulated luminescence, are such probabilistic assessments of time, and they usually use a symmetrical distribution of error expressed here with this Gaussian distribution. And this Gaussian distribution, of course, as you all know, is distorted by the process of dendrochronological calibration. In this example, the distortion is very small. Actually, it's getting even preciser. But in most cases, we have something like this. So the symmetrical distributed error coming from the laboratory is enlarged and is distorted in an unsymmetrical and polymodal way, which causes all the problems of dendrochronological calibration. So this problem is, of course, well known since several decades, but it took some time until archaeologists really learned to work with this kind of dating. And it actually influences our chronological concepts. With the chronological concepts, I would just distinguish two different types, directional and linear chronological concepts, which are, for example, based on typological arguments. I won't deal on this biologistic paradigm. And directional non-linear concepts like stratigraphy or seriation. Why non-linear? Well, I will briefly come to seriation, which has developed into what I would see the standard relative chronological method in the last decades, at least in European archaeology, maybe less in American archaeology. And just to give you one example, the seriation by correspondence analysis of Neolithic culture, of the Michaelsberg culture. Typically, we have this seriation diagram on the right side, where you see the increasing and decreasing frequency of types. But the thing that is new is, of course, the plot of eigenvectors, correspondence analysis being a multivariate statistical method. It uses the first, sometimes the second eigenvector to represent increasing or decreasing similarity, and thus actually being a proxy of time. But as has been shown by statisticians and by archaeologists, statisticians, just to mention Greenaker, 1984, the perfect seriation does not result in a linear arrangement, but in a parabola-shaped arrangement. So we have a non-linear representation of time in correspondence analysis. And this non-linearity causes some problems in interpretation. So here you see one of the maybe best published examples of a parabola based on real existing data. It was taken from Traxel's work on horse gear and chariot components in burials from late Bronze Age to Latène B, to Younger Iron Age, and it really gives a perfect parabola. So the question really is, and my students quite often ask me, why does correspondence analysis represent time in a parabola shape and not just in a line? Well, there are, of course, mathematical explanations which I'm not able to give you. It's too complicated for me as archaeologist, but there's an unmathematical explanation. So if we imagine the time axis and the similarity in types, it's obvious that the time axis is unlimited, the similarity is limited. It can be maximum if two graves are identical, and it can be zero if no correspondence is between two different inventories. And if we try to project this similarity on a time axis, it works quite well for a time, for a certain part of the time axis, but then it gets narrowed. And we have sort of the problem that even in the middle of a seriation, the similarity is zero, and it cannot be lower than zero. And therefore, the time axis, as it were, it's of course not a time axis, it's a representation of the time, begins to bend. So that's what actually is happening here. unmathematically speaking. And the reason, I think, is that we have to be aware that similarity between find units is an inverse proxy of time. Now, I will speed up a little bit here. The question is, how are chronological concepts actually influencing our archaeological interpretation? So, one of the major points is that typological method and seriation cannot cope with discontinuity. They are based on continuity. We have just heard that from Professor Klein as well. Continuity of development is the basic concept of these methods. Stratigraphy, on the other hand, is at least partly based on discontinuity. So when we really distinguish between two layers, we distinguish it because they are different, not because they are continuously developing. So there are two opposite concepts behind that. And stratigraphy is focusing on disruption, on destruction, on rebuilding, and so on. And therefore, I think this is one of the points that we can expect that concepts based on typology and seriation emphasize continuity of the cultural development, while on the other hand, concepts based on stratigraphy emphasize destruction, change of either culture or even population. And this might be one of the points where we can show that the way we use chronological concepts really does influence our way of interpreting archaeological processes. So, the last point I'm going to make is the probabilistic chronological concept. We are well aware that if we argue with radiocarbon dates, we have to cope with this probabilistic approach. But if we are really analyzing the way how archaeologists argue, we will find out that even in traditional archaeological thinking, probability plays an important role in, for example, historical archaeological dating. Most archaeologists that argue with the connection between for example, the ancient Near East and Greece and so on, they argue intrinsically with probabilities, but they don't express the probability as numbers, as natural scientists do. But as a concept, it's actually in our thinking from the very beginning of archaeological history. Also in the interpretation of stratigraphies, quite often probability is somehow important. It's likely that this is not late and not a long time after the destruction, and so on. I will give you just one example with the concept of the terminus post quem. So mathematically or logically speaking, a terminus post quem is something like an inequation. So we have a historical event X, we have an archaeological date Y, and theoretically we can just state that the point in time for Y is later than the point in time for X. I just reversed by accident the sign here, sorry. But what we actually do is we underline some kind of empirical probability distribution, which we could express graphically like this. So what we assume is that it's most likely just briefly after the historical event, and it gets less likely if we go on in time. So we actually attribute some kind of probability estimate without stating that we are doing that. So the same works actually with the terminus ante quem, but in a reversed way. So actually it would tell us only that something is before a historical event, but how it is argued in archaeological interpretation is with this kind of empirical probability curve. So we assume that it's more likely just shortly before the event than centuries before the event. So actually probability is not as unknown for archaeologists even before the times of radiocarbon dating and radiocarbon calibration. But of course, there it really comes as an essential approach. So if we are working as archaeologists, if we are trying to work with radiocarbon dates, we have somehow to cope with this probability approach. And there are, of course, already several methods. The first method I have found was the interquartile method proposed by Barbara Ottaway in the 1970s and 80s, maybe some other researchers as well. They tried to narrow this very large errors that radiocarbon dating produced. And they said, well, let's just take the second and third quartile of the distribution. This might be more realistic. And actually there are even examples when radiocarbon dating has been compared with dendrochronological dating. And it seems that this is not just bad guess, it works roughly. But this is of course not what we would expect for a sound methodological approach today. So the next step was wiggle matching, and of course I do not need to tell anything about it because Bernhard Weniger will, I'm sure, will be much more, will give you much more information about that. The most recent development since the 1990s is the Bayesian statistics. Thomas Bayes, an Anglican priest in the 18th century, was the one who actually formulated the Bayes theorem, which I'm not able to explain you here. I just quote this, but the basic meaning is that the likelihood of a given observation multiplied with likelihood of parameters gives the actual likelihood of things being like that. This is very unmathematically expressed, but that's what is really at the very basis of this Bayesian statistics in archaeology. If we translate this into archaeology, we can say that this statistical, the application of Bayes' theorem actually allows us to include a priori probabilities into the calibration process, and these might be archaeological context information like the attribution to a phase, the stratigraphical position, or any additional context information that we might have. Interestingly, Bayes, of course, was only able to formulate this on a theoretical basis, and it lasted almost 2 centuries until computing was able to develop algorithms to actually practically apply Bayes' theorem to complex chronological models. What I think is very, very interesting, that if we consequently apply such approaches like the Bayesian statistics, this means that the methodological border between ordinal and metric timescales start to disappear. So they are blurred, they are fuzzy, and it's a process of disappearing, of vanishing of this distinction. One last example of such a Bayesian application. This is the stratigraphy of a Neolithic tell that we have been excavating for 10 years in Western Romania. And with the help of the British team of Alistair Whittle and Alex Bayliss, who have just started an European program on this refined Bayesian dating, we have been able to reduce the errors of our radiocarbon dates, which are ordered stratigraphically, and you see the whole, without knowing the stratigraphic position, the errors of these datings would be much larger. It's the gray area in this diagram, and with introducing the context information into the model, we can narrow and we can order the dates in a much more reasonable way, so we can reduce the errors. The upper dates become more precise because we can neglect the older part of their errors, and in this way we can actually enhance the time resolution in such a model. So to come to the very end, what will be the future of dating the past? I expect and I hope actually that archaeologists cease to be just consumers of absolute dates done by others, by physicists, by dendrochronologists. Chronological modeling might replace step by step mere dating. And the dichotomy between relative and absolute chronology starts to dissolve. archaeological context information, I expect and I hope, will be regularly integrated into dating models. And eventually, we might expect that chronology will really become just the neutral frame of reference for archaeological reasoning instead of being one of its biases, as it is still today in many cases. Thank you very much.